Morning, everyone. First of all, I'm really happy to be here, to see all of you here in such a cozy place. I mean, if something goes wrong with the presentation, we still have the view, we can chat and have a great time. Today I want to share some thoughts on sustainability topic and how to make sustainable mobile apps. But before doing so, let me introduce myself. I've been around the block for around 10 years already, and I started coding and creating things. But now I'm mostly focused on leading group of mobile developers in my company. I'm mostly focused on making our processes smoother, collaborating with business development team, and things like that. One thing I wanted to mention that in my company, Nix, we don't work on some products, but helping our partners to create their digital solutions. So actually, we work in various domains and have really different and various use cases in our work. When I'm not working, I'm recharging with the help of free diving and hiking. Warning alert, if we met in person and you ask me about free diving, be aware I will spend an hour talking about that. So I warned you. Switching to the topic itself. One more thing I wanted to admit at the very beginning, that while sustainability is a broader term, today we gonna mostly talk about global warming and the impact that greenhouse gases have on climate change. And also I'll be frequently using the term carbon, which represents all the emissions and activities that impact global warming. So the primarily source of carbon emissions stems from the burning of fossil fuels. And why do we actually burn them? To generate electricity. Even though we as humanity strive for green energy, current technical and economical constraints, they unfortunately prevent us from eliminating high carbon sources entirely. Therefore, when we connect our device to electrical outlet, our hands are clean, but it doesn't mean that electricity is clean. So in this context, electricity can be considered as a proxy for carbon. And for a long time, we focused only on making physical things like refrigerators, cars, light bulbs, and everything energy efficient, overlooking software role in climate change. But recently, we've realized that software not only drives hardware development, but also controls it. So take a GPS app, for example. It updates your location. If it updates your location too often or doesn't stop doing so when it should, it wastes energy and increases carbon emissions unnecessarily. So everything is connected. Nothing works in isolation, and every small change can make a big difference. Bringing sustainability into our discussions encourages others to speak up and drive the change. Moreover, and I will show you, sustainability apps typically they perform better, they look better, they are more resilient. And these benefits are significant added advantages, but that doesn't mean that sustainability isn't value in its own. So motivation to build green mobile software that emits the least carbon amount possible is clear. But before doing so, we need to answer 3 key questions. What practices will help us? How do we measure their impact? And how much time and money should we invest in sustainability? So let me share how my team answers these questions. We are already aware that green software is carbon efficient software that maintains the same level of value for you and your users while emitting fewer carbon. So according to the Green Software Foundation, there are only 3 actions that effectively reduce carbon emissions associated with software. Before diving deeper, a few words about GSF, Green Software Foundation. It's the most influential nonprofit organization in the domain, which unites prominent minds, companies, and individuals in their desire to create green software. So these principles I've mentioned before are energy efficiency, carbon awareness, and hardware efficiency. They mean using less physical resources, less energy, as well as using energy more in more intelligent way, let's say. They are stack agnostic, so it's more like a mindset, like a vector, and we'll now take a closer look at each of them and their potential in reducing carbon for mobile apps specifically. First principle is carbon awareness. Carbon awareness is doing more when the electricity is cleaner and doing less when the electricity is dirtier, meaning when more electricity in the grid is generated using fossil fuels rather than low carbon sources like wind or solar. So an example of such technique, for instance, is shifting computations between hemispheres to take advantage of long sunlight hours during different seasons. This principle has been adopted by many cloud providers, and there are various solutions available that help developers implement it in their own projects. One example is the Carbon Aware SDK. It was recently on April, if I'm not mistaken, recently released by GSF. This SDK enables developers to gain insights into emissions levels across different locations over a specific time period. So it helps. It may help to take it into account and make greener software decisions. While carbon awareness is really vital for our environmental goals and can be adopted on the backend that your application connects to, it's not directly applicable to mobile apps due to the limited control of the user's devices, charging times, and locations. So next principle has more potential. It's energy efficiency. If our aim is carbon efficiency, this inherently includes energy efficiency, as energy, as you already know, is proxy for carbon. This entails minimizing energy consumption per unit of work. So in terms of data centers and clouds, energy efficiency is largely connected with, for example, maximum useful server utilization and avoiding idle times. When it comes to mobile apps, the best thing we can do is to minimize unnecessary everything, unnecessary operations, renderings, API calls, etc. So some optimizations are already implemented for us by operational systems, while others are still our developers' responsibility. And of course, there is no silver bullet, but however, there are still some standard approaches and practices we can use, which we'll explore now. Each mobile developer knows that one of the most battery-draining features is location tracking. And actually, it's not even about the device battery itself, but also potentially about a lot of traffic and data to store and process in the cloud. There are multiple business use cases that require knowledge about user location, but each has its own demand and its update frequency and precision. And it's crucial to use this as a potential for optimizing for such resource-consuming operations. I'll just share a classic situation with you. Your product owner comes and to the team and says, "We need constant location tracking. Could you do that?" Well, we can do that, but do we actually need it? I mean, why do we need this functionality? Oh, to track the user is near one of our online shops and send them a discount coupon, for example. But the thing is that we don't need constant location tracking for that, as mobile platforms have special geofencing functionality optimized on hardware level, actually, which triggers the app only when a user comes in or out in a specific region. And it's not the only way, of course, we can tweak such tracking and consume far fewer resources. For each particular business case, you should consider such thing as reducing location accuracy, registering for significant change updates only, tracking only if specific activity is happening, like a fitness session or automotive session, etc. This will allow you to keep a balance between energy effectiveness and business requirements. I'll give you one example from our experience. We had a client who wanted to create a location-based social network app. The main idea was to find a pole near you, to have a walk, grab some beer. And he already had a code base when he started working with us. And let's say we had some concerns regarding its quality. And one of the main concerns was that the application drained battery like crazy. So we began our discovery to find out the most significant causes of the issue. And of course, it was, among others, it was constant location tracking. So application tried to update location with the best accuracy and the best frequency that phone can only provide. Which was not actually needed to understand which users are within walking distance from each other. So just by tweaking these two parameters, meaning tracking precision and frequency, we decreased the impact on battery by 2 times. Location tracking is just an example of how knowledge of your platform abilities lets you achieve a lot of goals. Save device battery and make mobile solution more energy effective. At the same time, make the user experience better, as no one likes apps that drain battery, right? Or trigger high bills for mobile app usage, mobile data usage, sorry. So, and as well, prevent unnecessary data transmission, storage, processing by conducting initial data processing at the source. The final point introduces us to another broad topic, mobile network and optimization. So performing network operations in your app incurs energy costs. This is because networking hardware like cellular and Wi-Fi radios need to be powered up for the operation and stay active for some time after, draining the battery. So several factors influence energy consumption while you do your requests in your app. For example, cellular networks consume more energy compared to Wi-Fi. Also, weak signals and limited bandwidths lead to prolonged radio activity and are bad in terms of energy efficiency. Efficient networking in apps can prolong battery life. And generally speaking, here we have 2 strategies for optimization: minimization and differing. As for minimization, we typically consider caching and compressing transmitted data, as well as decreasing media quality and file size where possible. This choice can be made automatically, or user can make this choice, it doesn't matter. An illustration of this concept is video conferencing software that dynamically adapts streaming quality. So instead of streaming at the highest quality possible at all times, it reduces the video quality to prioritize audio when the bandwidth is low, or for cellular connection, for example. Also, this feature is typically activated when the phone's low power mode is triggered. So actually, this is just one more example of when the solution serves not only the sustainability itself, but also the user experience, because it's more important to hear other person without interruptions rather than see their picture perfect portraits, but with delays and without sound. Another networking optimization strategy is to defer it. First thing to consider here is to batch transactions. So the chart explains why it's important, because downloading content incrementally keeps the radios active almost constantly, resulting in energy wastage. So whenever feasible, your application should consolidate network operations. For instance, if your application displays advertisements, consider downloading multiple ads in one go and then displaying them gradually over the time, rather than downloading them as needed. Often, it's a great opportunity for optimization to delay network operations. Here, in a serial session, deferrable background session may help you. If you need to upload or download something, as they allow easily delay requests and wait for the most optimal conditions when iPhone is charging, connected to Wi-Fi, and so on. So this may come in handy for such functionality as backups, for example. And last but not least here, to emphasize the significance of limiting network activity to Wi-Fi. For instance, don't download a high-quality video over a cellular connection unless a user explicitly requires it. Such actions can waste bandwidth and may, as a additional not really good thing, they may result in carrier overage fees for the user. So switching to another topic. As I've already mentioned, when it comes to servers in terms of energy efficiency, it's important to avoid idle states. An idle server has a carbon cost for both embedded carbon and its insufficient utilization. But we can't avoid idle states for a personal device. So our mission here is to ensure that this state isn't interrupted without need, as waking the system from the idle state consumes energy because it involves waking up the CPU and other components from their low power modes. So work less in the background and don't try to fool system by, for example, constantly playing silent audio in background, for example. Also use timers wisely, specifying suitable timeouts and invalidating right after you don't need them anymore. Talking about timers, frequently apps they employ them without genuine necessity. In many use cases, instead of focusing on fixed time intervals, it's better to use event notifications for system-provided services whenever possible. So the next topic is things to remember when you work with notifications. So use local on-device notifications where possible, of course, to reduce strain on network hardware. And remote notifications provide several push priorities levels, from immediate delivery to delaying until an energy-efficient time. So unless notification genuinely needs to be delivered immediately, opt for the deferred delivery priorities. Now let's talk about some energy-wise design considerations. If your app primarily uses standard windows and controls, you likely won't need to be overly concerned about its efficiency. However, most real-life products want to stand out and to be super appealing to users, use some eye-catchy design. So these are things to remember. To remember and to ensure your design is energy efficient. First, remove drawing when your app is or its content is overlapped by other views, cropped or off-screen. Remember I told you about those location-based social network app. So location tracking was not the only problem we had there. One of the first crucial optimization we've implemented in legacy code was reconsidering the map screen. Because initially when the user opened it, the phone was hitting up like so much you can fry an egg on it. And it's all because the app was trying to show hundreds of pins on the map. And not only was it too much for the GPU, but also for the user, because map was super cluttered and it was really hard to navigate and operate with. So by implementing proper clusterization mechanism, we both made the screen much more energy efficient and usable at the same time. Next thing, reduce the use of opacity, particularly in views with translucent blur effect. If you must use opacity, at least be sure that content under these opaque views is not changing frequently. We can consider the implementation of dark mode in apps as a tribute to trends or simply as a nice design for your users. But in fact, it has a deeper meaning for saving smartphone resources since it reduces screen brightness. According to different researchers, translation from light mode to dark mode can result in around 40% reduction in power consumption, which is true for modern displays and depends on design peculiarities, of course, and screen brightness. Last thing I want to talk about in terms of energy efficiency in mobile apps is native versus cross-platform. I know I'm speaking at iOS Native Developers Conference, and the answer may be obvious for you, but I told you that we don't develop our own product, so sometimes we need to work with other teams or with already made solutions, and our customers they have different considerations, different circumstances and so on. So we have this question in our team sometimes. And of course, again, there is no silver bullet actually. However, in terms of sustainability, native development is the better option for sure, as native apps are still more optimized for their target platforms, and they doesn't rely on additional layer and the bridges or as cross-platform solutions do. Moreover, based on research I found in Green Software Foundation resources, Swift is nearly 40% more energy efficient than Dart and 60% more so than JavaScript, while also being faster and more optimized in terms of memory usage. So if you want more information, feel free to look into the study itself. It compares 27 programming languages based on how each one solves 10 different programming problems, taking into account metrics like energy consumption, memory usage, and time. So now let's transition to last principle we'll discuss today. Devices produce carbon emissions throughout both their manufacturing and disposal phases. For some devices, the carbon emissions associated with manufacturing can surpass those created during actual usage, resulting in much larger embodied carbon footprint than the emissions from the device's energy consumption. And this is the case for user devices like smartphones, where production, upstream transportation, and disposal processes account for around 3/4 of emissions. While certain companies like Apple, for example, have taken steps toward carbon neutrality with certain device models, this is still the exception rather than the rule in the market. So in this perspective, hardware represents carbon, and since our objective is carbon efficiency, optimizing hardware efficiency becomes critical. For end-user devices, this means extending the hardware's lifespan. That's why our software needs to run smoothly, not only the latest device models, because when hardware fails to or unable to handle current demands, it is often decommissioned. And while hardware, of course, inevitably wears out over the time, developers can construct software that does not push its limitation unnecessarily. And yes, sometimes it's connected to the fact that you can't use those fancy new APIs from WWDC in terms of compatibility. But now you know at least that it has deeper meaning. The next thing I want to cover is answering the question of how we can measure impact of previously described or any other practices, actually. There are several ways to do so. The greenhouse gas protocol is widely recognized framework for measuring, managing, and reporting greenhouse gas emissions. The GHG is a protocol to measure total emissions. So to calculate overall software carbon emissions, we need detailed data on energy usage, carbon intensity, and the hardware on which the software runs. And it's even harder if you use open source software because you don't have such level of visibility. So it's crucial to note, however, that the total is only one indicator that provides insights into a specific feature. And there is another protocol, the software carbon intensity specification. It is methodology developed by GSF, Green Software Foundation, again, meant to score a software product along a sustainability dimension. So while GHG protocol measures total emissions, which is not every time, we don't have resources to measure it sometimes, the CSI determines emissions rates. So in automotive terminology, the SCI, is similar to a kilometers per hour measurement, whereas GHG protocol is concerned with the car manufacturer's entire carbon footprint and all of the cars produced each year. So your SCI score will drop if your application is more energy efficient, hardware efficient, and environmentally conscious. To determine your SCI score, you decide on the software components to consider. So it doesn't matter, do you measure the whole software product or just some component. You pick a functional unit like users. So the dimension actually that defines your ops scale. Measure emissions directly or use a model. You can derive multiple CSI scores for an app. For instance, a streaming app may look at carbon per minute or per user daily. And sustainable practices, they help reduce your SCI score. If you want more information on that, you can scan QR code. Green Software Foundation has really a cool guideline how to apply it. In practice, finding time to calculate this score and apply other metrics isn't always easy, right? We all have our deadlines, business wants to our constant feature delivery. However, to ensure your solution is battery friendly, it's always useful to check the debugging gauges in Xcode while testing new feature, or to delve deeper using a complete set of Xcode instruments. Building eco-friendly software doesn't necessarily cost more than traditional development methods. You might have some upfront expenses, like setting aside to refactor code for better sustainability. But these initial investments, they often lead to big benefits. They not only make your software greener, but also more efficient and easier to maintain over the time. Adopting green software practices can help companies achieve their environmental, social, and governance goals, which are becoming increasingly important to investors and key stakeholders. Additionally, for developers searching for new opportunities, a company's commitment to sustainability is becoming a key factor. So emphasizing a commitment to green software could be what's needed to attract top talent to your team, for example. While we haven't addressed every possible strategy here today, I hope now you have an insight on why mobile app sustainability matters and some considerations on how to achieve this goal. I first spoke on this topic since 6 months ago, and since then much has changed. For instance, new projects and initiatives have appeared on the GSF website. Some of them are on their initial stages, while others have been officially launched, but they are still young. Like, for example, carbon awareness decay I've shared you previously. But it's clear that there is a buzz of activity, and the industry's interest is only set to increase. For your next step, I recommend exploring the list from, again, GSF, which contains a wealth of interesting resources. This project is currently in its incubation phase, and Green Software Foundation doesn't officially endorse it as definitive. But if you're looking to expand your knowledge, in my opinion, I think it's a great starting point. So I'm considering it will pay off. I think that's it. It's been a pleasure to share my thoughts today with you. Let's stay in touch. Let's connect. It's my link to my LinkedIn account. So let's connect, and thank you for attention. Maybe you have questions. I'm ready to answer.